All right, we're broadcasting. How'd you guys do on the homework last week?
It was fine.
Yeah? Victoria, how'd you do?
I was fine. The second quiz was kind of hard. I didn't
Yeah?
do very well first.
I think I missed one on both, and then I retook them.
Yeah, okay.
But it seems like it's going to get worse and worse.
Yeah, I don't know. Who knows? It might.
Yeah.
All right. Should we get started on the group assignment?
Yep, go ahead.
Would you guys do it? The whole thing?
I just did the first part this time. I didn't do the second part.
What about you, Victoria? Victoria?
Victoria, are you there?
My internet sucks.
Okay. We'll be patient with you and your internet.
Sorry, I just missed everything you just said.
Oh, we were asking if you. What did you do the part 2 or part 1 and 2 or just part 1?
Just part 1.
Okay.
Zach, did you do part 2?
Was I supposed to do?
I did. That's what it told us to do.
It told us to do
Oh
part 2?
man, I should.
Yeah, it told us how to do it.
I didn't do very well because I just didn't even think about school today.
Wait. So, meet with your groups. Record your group meeting and post after the group. Clarify their understanding of part 2. Oh, so, okay. I guess I just did it the same as the prior week where we do part 1 on our own and part 2 with our group.
Yeah.
But then this week it says,
Yeah.
just discuss any questions you have about part 2 with your group. So I guess I kind of just skimmed over and missed that.
Yeah, I honestly just assumed that they were all going to be like that, so.
That's right. It's not too hard.
All right, so should we just go over part 2 then?
Sure.
Zach, I'm sorry, you said you did it already?
Yeah, I did.
Okay, well then you can guide us through this.
Okay.
For us slackers.
There's only 4 values possible, so 1, 2, 3, and 4. And so each value is 1/4 at 0.25. So you take the value and the probability proportion and multiply it together. And so the sum of them all would be 2.5. So that would be the mean of the discrete random variable. If that makes sense. I don't know yet.
Hold on. Calculate the mean of this discrete random variable. So what would x, hold on, account the value times proportion. So it's just 1 times 2 times 3 times 4 times. So it's 1 times 0.25 plus 2 times 0.25 plus 3 times 0.25 and plus 4 times 0.25? And then that's your answer?
No. Well, yes, sorry. You multiply them all, then you add it all together, yeah. So it'll be 1 times 0.25, then 2 times 0.5, then 3 times 2.5, then 4 times 2.5, or 0.25, then add all those together, you get the sum.
which is 2. Okay. Yeah, 2.5. Okay, so that's easy enough. Did you get
Yeah,
that,
pretty
Victoria?
straightforward. Yeah,
Okay.
I get it.
All right, let's go ahead and go to number. Is there only 2 on here?
Yep.
Yeah.
Okay. Go ahead, Zach.
Number 6, I'm going to calculate the standard deviation of this discrete random variable. It's the same thing, so the sum stays the same. And so what we have to do is take all the probabilities and then square it. Well, kind of. So you take value 1 and subtract it from 2.5, the sum, and then you square it. And then multiply it by the probability, so you 0.25, to get the variance. And so you have to do that with each one. So we have 1 minus 2.5 squared, then 2 minus 2.5 squared, then 3 minus 2.5 squared, and then 4 minus 2.5 squared. And then multiply all that by 0.25. There's some variance of 1.25.
We lost Zach.
Did we?
We did. All right, I'm gonna run and go get my scientific calculator while he joins back in.
Good
Okay.
call. I will do that too.
Okay. We got back just in time, Victoria.
Oh, nice.
Okay.
Does your internet suck too, Zach?
I don't know. I'm out of 10 right now, so it should be fine. Okay. So, did you lose everything I said?
Yep,
No?
Ah.
Oh.
I did.
Yep.
So, the first part's the same. The only difference is that the fourth part to do, second part I mean. So you're taking 1, the value, subtracting it by the sum. So it'll be 2.5, and
Okay.
then you square
Why
that.
do you... Oh, okay.
And then
Why do you
multiply,
square it?
because you're trying to find the variance.
Oh, so it's the same as last week when we were trying to find the standard deviation for things.
Yeah, so
Got
you
it.
square it, and then you multiply it by the probability, so it'll be 0.25.
Okay.
So then you do 2 minus 2.5 times 0.25, and the sum variance is 1.25, and to get the standard deviation, you have to square root 1.25, and that equals 1.118.
I'm putting this in just to make sure I'm calculating correctly.
So on the answer key, it'll give nice charts to help you understand what I was talking about. If that helps at all.
Say that again, Zach?
If you look at the answer key, there's a nice chart of how the work is supposed to be, how it looks for the work to be done. Help you understand more step by step.
So are we adding each of them together? So looking at the answer Q1. Okay, looking at the answer Q1.
Okay.
On the 4th column, are we adding all that together?
Yeah. Once you do the multiplication inside each box, you add them all together.
Okay. That's 1 minus 2.5 squared. Sorry, Zach. I just want to make sure I get this right.
Thanks for doing your part, Zach.
No problem.
For us slackers who didn't read it, right, Victoria?
Whoops.
Now we know next week, though, to, like, look at it. I'm almost done.
Okay.
Did you figure it out, Victoria?
I'm almost done too.
Oh, I did the same one twice.
So two of the numbers are the same, or I guess
Are they?
two.
Because I got...
Yeah.
Okay, so I didn't do it wrong then.
Nope, you're good. Because I thought the same thing, but I just kept going and got the right thing.
Okay, so hold on. 0.25. Okay. So then 5. Oh, okay, so... Okay. Plus 0.5625. Okay, I got it. I'm good to go.
Here we go.
Sorry. Yeah, sorry that took me a little while.
It's okay.
Okay, should we just start the quiz then?
I guess so.
Are you good to go, Victoria?
Yep, we're good.
Alright, here we go.
Yes.
Uh-oh. Hopefully my internet doesn't
Go out on you.
give out. Yep, it should be good.
Okay. Human blood can be classified into one of our basic groups, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table.
Does that table show that there's more people with O blood than any other?
Yeah.
I didn't think that that was true.
Is it accurate? It might not be accurate.
I don't think it is.
Sure. I thought that that was the rarest.
It is. I
Oh.
thought A was the most common,
Yeah.
right?
And then it was A, B, and then O. That's what I thought. But I don't know. Okay, anyway. So the blood types and the proportions given in the table above define the probability distribution.
I would say true
Why would you say true?
because it adds up to 1.
True, yeah. Blood types and the proportions given in the table above define a probability distribution. That makes sense. Okay, so what is the probability that a randomly selected person in the United States has type O blood? Wouldn't the answer be 0.45?
Yes.
Would it be 0.45 or just 0.45?
Either
would say
one would
0.
work.
Okay.
Let's see. I'll put 0.5. That's what I'm going to put. I'm going to put 0.45.
0.45. Okay. What is the probability that a randomly selected person will not have type O blood? So it's just 100 minus 45, right? Which
Yeah.
is 55. So it's 0.55?
Yeah, 0.55.
This seems too easy, or is it just me?
It does. It just says
This is pretty easy at the beginning. It probably gets difficult later on. But then I could be wrong and just
We could totally just bomb this.
Hey, whatever.
All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round answer to 3 decimal places.
So there's 7.
Right.
There's 7 bowls, yeah.
So it'd be
So wait, don't we have to like, oh my gosh, I'll be right back. I need a pen and paper. I'll be right back.
Aren't we just doing like what we did in the section 2 of the preparation, pretty much?
I know how to figure it out. It's just going to take me a second. What, sweetheart?
We gotta go read the books. Yeah, never once.
Okay, wait. I'm confused with what numbers to place where. So this one is using the first chart, so number 5. Chart 2, number 5, right?
Yeah, that's what I'm doing.
So
That's what I thought it was.
what would take place of the 1/4?
We just watched.
Like,
Yeah.
1
1
7, because it's
Oh,
a
yeah.
1 in 7 chance.
Yeah,
So the nearest number I found to the decimal would be 0.143.
0.143 was the answer you got?
Yeah. Because if you times that by 7, it equals 1.001.
Okay, hold on.
This might take a little while.
And I said that by trial and error. So, I don't know.
Okay, hold on 1 second.
You guys get.
I'm
Sorry, I'm working,
Almost.
so.
I'm almost done. I think I'm totally wrong, but I got 3.92.
I don't know, I got 3.
I must be really slow with my calculator.
So Zach, I used the first table. So in the value, it's 1 through 7 because there's 7 samples, and then I took whatever the next column is, but then 1 and 7 equals out to 0.14. So then it's 0.14 times 1, 0.14 times 2, 0.14 times 3, and so on until you reach 7, and then you add them all together. Right?
No,
Okay. What
because
did I do?
they're asking for the probability. And what
Yeah.
you were doing was you were doing. I think you were doing the mean. You're trying to calculate the mean.
Oh, I did. Oh, so we only need the 0.14
Yeah. Well, 0.143.
because it rounds up. Okay, okay, I get it. So I just took it way more steps further than what I needed to.
Wait, so it's just 0.43?
No,
Point
it's
one
0.143.
0.143, that's what I meant, sorry.
Yeah, so Victoria, you and I were doing the
Okay.
same thing.
We were
except-
like going the next step that we
Yeah.
didn't need to do. Okay.
Sorry, Zach's probably like, what the heck is it taking him so long to figure it out? Okay, number 7. Go ahead, Zach.
Okay, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, and little evidence that dogs can detect bladder cancer.
I would say there is little evidence that dog can detect bladder cancer because it's not proving anything. Because
I agree because it says that 22 out of 54, that's less than 50%. And it says it is very unlikely that a dog would do this well by random chance alone, but that doesn't mean that it's not likely. It just means it's unlikely. Right? What do you think, Zach?
It's hard to say if you follow math, if you follow the question. Because I mean, the question is saying it's unlikely the dog would do this well by random chance, or you're going to follow what we're being taught in math. So it depends, I guess, what the course wants to do. The teacher is, I don't know, it's very opinionated, which is statistics is all opinion. So it's either
Yeah.
way. I mean, that's a strong evidence just because it's unlikely the dog would do this well by random chance alone, but it is less than 50%, so it's hard to say.
I'm going to go with little evidence.
if I didn't like overthink it, I would choose little evidence. But if I think more about it, I would feel like it provides strong evidence. You know, but I feel like that statistics is, I don't know.
Statistics is always very skewed, no matter what you do. It's made to make it's made to make a business idea look right, even if it's wrong.
Yeah.
Yeah.
All right. Go ahead for the next one, Zach.
Okay. M&Ms are small chocolate candies. The M&Ms website previously indicated the United States the distribution of the colors in the bag of plain M&Ms is given in the following table: 0.13, 14, 13, 124, and 20. What is the probability of drawing a red colored candy? 0.13. What is the probability that a randomly selected candy is green? Add all the numbers.
0.16 because the rest add up to 84. 48.
What is it? 0 what?
0.16.
16. What is the probability that the randomly selected candy is not green?
0.84.
Okay. 0.84.
Right?
This just feels too easy.
It does.
The ACT scores of students admitted to a medium-sized public university in the western United States were taken from CapEx.com. The following summary statistics were calculated. And there's that. Use the information from the public university to answer the following questions. Half the observations are less than or equal to what number?
I don't think I understand this question. Is
Half
that
the
silly of me?
What number?
I'm continuing to read it over and over again. I don't understand it either. Okay, so half of the observations are less than or equal to what number? So do we have to put them in order first? Wait,
No,
no?
the numbers won't mean anything for order.
Yeah. I just figured that out. Half of the observations.
Review? Why does it say review?
Maybe it's like one of the last tests where if you're just in the
Oh,
range.
so it's either 20. It's probably 24
Why do you say that?
because the median is the middle. So it's either 24. Anything less than 24 is equal to that number.
Oh, because half, and
Yeah.
so the median, which is 24, are less than or equal to. Okay, and that makes sense now.
Based on the information, the top 25% of the students scored above what number?
Hold on, Victoria, did you understand 11?
No, I'm so confused. I'm
Okay,
sorry.
so it says half of the observations are less than or equal to what number? Well, the median means middle, so the middle number,
Right.
and the median
Okay.
is 24. So half of the observations are going to be less than or equal to the median.
Got it.
Which is,
Okay.
make sense?
Thank you. Yep.
Go ahead with 12, Zach.
Okay, 12 is the top 25% of students scored above what number? And that would be quartile 3, 27.
Okay.
Because 4 would be the 100%. Or
Yeah, it's in quarters, so that'd be that's the one. And then the last one, which of the following statements is not one of the 3 rules of probability? That would be, well, for me, it's if the probability is high, then the probability is positive. If the probability is low, then the probability is negative. That's not good probability.
wait. On number 12, wouldn't it be 35? Because if you're looking at a chart and it's broken into 4s, the third quartile would be like the 75% range.
Well, the maximum is the highest number there,
Oh, okay.
and the minimum is 14. That's the lowest number there.
So the minimum, so 22, 27. Still a little bit confused on that. But so if the minimum's 14, the next one's 22, then the next one's 27, and then the next one's 35. And it's
Well,
asking for the top
So
25%.
the top is 35, right?
Yeah, the highest number that they have on the graph is 35. The lowest number is 14.
Okay.
And so quartile 1 and quartile 3, I'm not really, I just know it's a quarter of it. I'm not sure if it's an average or if it's a middle number. I just know that's the quartile. So the minimum and maximum wouldn't be it. It'd be a quartile, either the first quartile or second quartile. The first quartile is the lower end, I think. Yeah, it is the lower end. And the third quartile is the higher end.
So it couldn't be 35 because 35 would be the top number, and it has to be what they scored above.
Yeah, with 25% scored above.
So what's Q2? It doesn't say, but like.
Q2
Wouldn't
is
that
not.
just be?
So
Say that again, Zach?
I don't think quartile 2 is used very often. the quartile 2 is kind of the median.
Right.
Oh, okay. Okay, then I'm good. I'm good.
Okay.
Okay, sorry.
And the last one is the probability is high and the probability is positive. The probability is low, then the probability is negative. That's not even, yeah.
So it's number 3.
Yeah, for me it's C. I don't know about you guys.
Hold on. If the probability is high, then the probability is negative.
Okay. The probability that an outcome will not occur is 1 minus the probability that it will occur.
Yeah, it's number 3. Sorry. Okay, I submitted.
What did you get?
Oh, we missed one. I missed 2 because I didn't completely prepare because I didn't do section 2. So I had to mark that I didn't prepare. So I missed 2.
Wait, what's the other one that you missed?
Number 7.
Oh, okay. Oh, sounds good. We're
Hey,
done?
yep, are we meeting on Wednesday?
Hey, that didn't take... Yes, that's great. This didn't take very much time, guys. We're getting better.
No, okay. Victoria, can you get the URL from mine page
Yes.
when I'm done and post it? Since
Yes, I
can't
can.
even seem to.
Oh, yeah.
Yeah.
Awesome. All right. See you guys on Wednesday at
8
8.
o'clock.
8. Mountain Standard Time.
Yep.
Thank you. All right. Bye, guys.
Bye.